All right, Java students, let's start thinking about this idea of encrypting and decrypting data, which is going to be the center point of your problem and your project for this section. At the core of this encryption section is this idea of the ASCII table, the ASCII table. There is an equivalence between characters and numbers in the way that we store information in coding. And you'll see that if I try to find the letter A here, you'll see that it is associated with the decimal value of 65, B with 66. Exclamation point is 33, a space is 32. And we have all sorts of other capital and lowercase letters that have decimal values associated with it. I technically have lots of other types of information associated with it, but we're mostly concerned with the left and the right-hand sides and how they line up. And so you'll see that 0 is null, and then a bunch of like the different types of specialty keys like shifts and returns. And we generally want to stay out of this section. We kind of only want to start with 32 and end around 126. That's a nice range of values. So just a little tip for you, if you have to do some shifts of large values, then if the value goes above 126, you want to enforce that it goes back down to 32 and stays within this range. Otherwise, we're going to get some weird characters showing up as we convert things from one to another. So what is it I'm exactly talking about here? Well, let me show you in here. I can have a character called letter, and I'll set it to the letter A. And if I print out this letter, print this out, I should see nice and clearly that the letter A is printed out, the lowercase one. Beautiful. But what if I were to do something weird like this? Equals an int cast of my letter. Notice Java allows this, which might be surprising. Now, just to double check something, am I able to take a string, word equals hello? Can I cast this to another num? Just so we can kind of see clearly here. Int word, no. So we're not allowed to cast a full string. Think of a string like an array of characters. This array has 1, 2, 3, 4, 5 characters that make it up. And so I can't just cast them all directly like that. It doesn't work. I'd have to split them up down into individual characters, a variable that we haven't really used at this point in time. But there we go. It just stores a single character inside of quotation marks, like this. Sorry, I guess you call these apostrophes. And so quotation marks are for the strings. I'm mixing up my English terms now. And so what I have here is if I print out num, we'll see what the equivalent to A is in terms of an integer. So we have A, lowercase, and 97. Back to our ASCII table, and A is 97. Let's test another one. How about capital R? It should be 82. So if I put in capital R here, and then I let the casting kind of go down, I have an 82. Okay, well, that's interesting. So now I have some ability to convert from characters to numbers. We can use this to create something called a Caesarean cipher, a message that has each of its characters shifted by a certain amount. And so what we're going to be doing is building a simple encryption and decryption program that allows us to take in information and then convert it down to the actual shift its values around to different values. Either that's a number or a letter. Although we'll see holding it in numbers is going to be tricky because, well, those numbers, when read side by side, can be misinterpreted. For example, if I converted hi, let's put this in a comment, hi to ASCII characters, H is 104, and then I is 105. Well, they're right beside each other. So how do I write these things beside each other? Because if I wrote it like this, and then I fed it back in, is this 104105? Is this 104 105? Is this 104 105 all separately? It's kind of hard to know. So if you held it in this format, you'd need to have some kind of a delimiter in between, making sure that we kept those numbers separate from one another. Just a little tip in advance for what we're going to be thinking about in this section. But for now, I'm going to create a public, actually not a void, I'm going to return an int. And I'm going to call this character cast. And I'm going to allow this to accept a character called a letter. And this might seem a little bit unnecessary, but just let's build all the pieces of functionality here to make it really clear. And really what I'm going to return here is the integer form of this letter. So I'm casting the letter into an int. So basically, I've just, what I did earlier, I'm just kind of creating a bit of a shortcut to do so. So let's create a file decryptor here. I haven't made anything for this yet, but a file encryptor as well. New file encryptor. So I have access to all these different pieces of functionality in this running code here. Now you could split this up into different sections for running. I'm just going to do it in here for the sake of the tutorial. And in my encryptor now, I have the ability to cast a character. Let's go with the character let's go with the character 0. And I want to print out what this returns to me. So let's take this and actually shove this around in the right spot. So what is the result? This character 0, what is its actual value? 48. Let's find 48. And indeed, so there's a difference between the number 0 and the character 0, because this is not a number, it's a character. And so it has a value as a number of 48. But with this method, now I have the ability to just type in whatever letter or character I want in here and find out 65 for capital A. What about an empty space? Let's just run this one and see what the printout might be. And here we have 32, which is indeed the thing for space. Well, hopefully it makes sense that if I have a ability to, I want to return a character, convert from a character to an int, should have the ability to convert backwards, and the answer is yes. I'm going to call this convert back to int, or to char. And I accept an int from a number. And I allow this to return my number cast to a character. I'm doing the reverse, so kind of two sides of the coin here. I'll let you add in all the Java docs and stuff later on. If you feel like doing so, you should. And let's see what if I take this encrypt character to cast, and I'm going to store it in an int as a num, so I'm storing in that value, and then I'm going to print out sending this to my encrypt, convert back to char. I'm going to send my num there and print it out. So this, if I convert, maybe let's go with z, I convert it to an integer, and then I convert it back into a character, it's back to z. So I've now been able to turn it from one form to another and back again. But here's the real thing I want us to see. If I took the letter A and then I converted it back, but I added 1 to it, what is it I'm going to have return as the value that comes back? It's going to be the next one in line, the letter B. So I've been able to cast my character to an int, change the value, and then cast it back, which then results in there being an updated value. Very interesting. So this is going to allow me to actually change information from a file on a bit more of a mass scale. So something that I'm going to want to have my file encryptor able to do is actually have some access to my file read and a file write. Get this in here really quick so that I have access to the utilities that I've built elsewhere in case I want to use them in my project somewhere. So what if I wanted to make I'll just make it void for now, just so it's a printout. We can always update this after a little bit. I'm going to call this encode string. And it's going to accept a string, which is some message, and it's going to print out an encoded version of this message. So how are we going to go about doing so? Let me show you the algorithm that you'll be using again and again in this section in different combinations and contexts. So the thing that I would like to do here is actually take a look at each individual letter of this message and change it so I can kind of cast it and change it into some new value. And I could think about writing this to a file later, but for now we're just going to print it out. So follow along with me as I kind of go through this here. I'm going to call this string the encoded string at first, which is going to be an empty string that I'm going to be adding information to as I go along. And next, I'm going to take the char letter inside of my message, inside of my string. And so, it doesn't want to let me do this for the string. We have to build a different, that's right, we have to build a different algorithm for this. I'm going to go int I equals 0. I is less than my message dot length, I plus plus. So what I'm doing is I'm looking at I'm looping for as many times as there are letters. Loop as many times as there are letters. So if the message is just yes, it'll loop 3 times. If the message is hello, HELLO, it'll loop 5 times. So I have the ability to look at each individual letter of the string. So how do we actually get information about a single character? I'm going to call this character my temp char, and it's going to be my message dot char at I. Strings have a method called char at, where I can just pull out the single letter at a given position, starting from 0 and ending in at length -1, just like any array. And so char at I, the first time this loops will be the first character that I'll store. The second time it'll be the second character, and it'll loop every time it loops, it'll be the next character until it's the last one. So I've now been able to snag each character from, oops, let me set this right, from the string, one at a time. And now I can do something to this, which is I'm going to now do the converting. So I have the ability to cast to, well, different content here. So I can either build this custom in here, I can use my method, my references up here. I'm going to call this the letter val equals my character cast of this temp character. You could also just convert it directly. I just like using the other methods that I built here to kind of showcase how I use helper methods here. And now what I want to do is have a character, which is the new char, equal to the convert back to character of my letter val plus 1, plus some value. Now, something else I can consider doing is, do I always want this to change only by 1? I can make this more generalized by the shift value here. How much do I shift this by can be customized by whoever calls this method. So I'm allowing there to be a custom shift present if I need there to be. Sorry, I'm just going to make sure my recording's still going just to be safe here. Looks like it's going fine. Cool. And so here we go. We have a shift value that's applied to this new character, and I'm converting it back, which now means my encoded string is going to tack on that letter as the next character in that string. So I'm slowly building a string together here. And after all this is said and done, I'm going to print out this encoded string and see what it is that pops out the other side with this shift. This should be good enough to run this here. Let's go into my runner, and I'm going to go back here, and I'm going to use my encrypt, and I'm going to go encode string. And just to make sure this seems really clear, I'm going to go ABC, ABC, capitals and lowercase. I'm going to have it shift by a single space. And we're going to see what happens to the resulting message once I've applied this logic to it. I have BCD, BCD, capitals and lowercase, because in the ASCII table, A, the next thing is B, if I add 1 to that value. Same with lowercase a, the next thing is lowercase b. So what I've been able to do is actually take that message and encode it. Let's see one that's a little bit more clear here. Here is my secret message with an exclamation point. And if I run this, shifting it by 1 over, I get this scrambled message that looks very much uninterpretable because I now have every single letter in this shifted over by 1. You can tell for yourself if that's the case. And what happens if I made it -1? Well, now I'm able to see it's a different set of characters based off of the shift the other direction. What if I shift it by 0 characters? What should the result be for that? If I add nothing to it, it just converts right back to the same message. So I have the ability to customize my encryptions in different ways. And this is the basis of how we're going to be working with our files in this section. And for the most part beyond this, I'm going to let you wrestle with figuring out how to solve the creation of this program. You have the basics lined up for you here. How might you create a simple decryptor? Well, if my encryptor allows me to shift the values by a certain amount, one direction, my decryptor should be able to shift the values in the reverse direction. That's something that you'll need to build right off the bat. But there's some other challenges in this section that you'll have to uncover as well. For example, the ability to add a different type of encryption. What if you wanted to have an encryptor that was a little more clever than just shifting every single value in it? What if you shifted every other value after you shifted it first? So for example, I could do a simple encode of having everything shift over by 1 the first time through, but then the next thing I do in my runner is, so step 1 might be shift everything over by the same value. And maybe step 2 is using a different tool that you build, shift every other letter over by a different value. And then maybe step 3, shift every third letter over by yet another value. Meaning that by the end of it, the decoding of that string is going to be quite difficult unless you know how to reverse the order. Your decryption would reverse this, and then reverse this, and then reverse this. The reversal has to be done in the reverse order as well. Otherwise, things are going to get all muddled up as you go along. And so what I want to see you doing is taking information from files that you are able to process and that you're able to encrypt. And the main file that I'm going to give you to work with for some of these things is this all words file that I'll have shared in this project package with you here, which includes a master list of a huge number of words from the English language here. You can see that there's about 466,544 words in here that you're able to pull into your project and actually manipulate in different ways, with the idea of potentially encrypting and decrypting some information. But the main thing that you'll be using this all words list for is in the most challenging and final part of this section, which I'll talk about in the next video.